And what enormous potential does Toyota's solid-state battery have for other fields? The potential of Toyota's solid-state batteries in fields other than electric vehicles is vast and promising. Here's how. 1. Aircraft. The high energy density of solid-state batteries could significantly reduce the weight of aircraft batteries, leading to higher fuel efficiency and longer range. The fast charging capability of solid-state batteries could reduce waiting times at airports for aircraft refueling. Moreover, solid-state batteries are less prone to fire and explosion than traditional lithium-ion batteries, enhancing aircraft safety. In practice, Airbus is researching solid-state batteries for electric aircraft, collaborating with the startup Adore-E to develop solid-state batteries capable of storing 10 times the energy of current lithium-ion batteries. Similarly, Boeing is researching solid-state batteries for electric aircraft and has invested in the startup Kreisel Electric, specializing in developing solid-state batteries for electric vehicles and aircraft. 2. Military vehicles. Solid-state batteries could significantly extend the operational range of military vehicles, allowing them to operate further without refueling. Additionally, the high energy density of solid-state batteries could power stronger weapon systems and advanced electronic devices on military vehicles. Solid-state batteries may require less maintenance than traditional lithium-ion batteries, reducing operational costs for military vehicles. According to some sources, the Israeli military is also researching solid-state batteries for military vehicles, collaborating with the startup StoreDot to develop solid-state batteries capable of fully charging in 5 minutes. Overall, Toyota's solid-state batteries have immense potential to revolutionize various industries, including motorcycles, aircraft, and military vehicles. With benefits such as longer range, faster charging, higher efficiency, and improved safety, solid-state batteries could make transportation more efficient, sustainable, and safe in the near future. 3. Motorcycles. Solid-state batteries could provide a range of over 1,500 kilometers, 5-10 times greater than current electric motorcycles. This would make electric motorcycles more practical for long-distance trips and attract a larger customer base. Additionally, the ability to charge fully in 10 minutes would make charging electric motorcycles more convenient and faster compared to the several hours required by current models. Most notably, the high energy density of solid-state batteries would enhance the speed and torque of electric motorcycles, providing a more exciting driving experience. Recently, Honda has partnered with GS Yuasa to develop solid-state batteries for electric motorcycles, aiming to launch a model utilizing solid-state batteries by 2025. Yamaha is also researching solid-state batteries for electric motorcycles and has showcased a prototype at the Tokyo Motor Show 2023. However, what are the challenges in manufacturing and commercializing this type of battery? It is clear that a high energy density equivalent to around $1,000 could lead to a lighter and more efficient design for solid-state batteries, reducing the overall weight of vehicles and increasing range without sacrificing performance. So, why does the manufacturing and commercialization of this type of battery take time? 1. High manufacturing costs. Solid-state batteries utilize materials such as lithium, sulfur, and rare earth elements, which are expensive and difficult to extract. Moreover, the manufacturing process for solid-state batteries is more complex than traditional lithium-ion batteries, requiring specialized equipment and advanced techniques. 2. Technical issues. Stability is crucial. Therefore, creating a stable interface between the components of solid-state batteries is a challenge, which could lead to short circuits and other safety issues. Additionally, manufacturing solid-state batteries with desired sizes and shapes consistently and efficiently remains a significant challenge for manufacturers to overcome. 3. Infrastructure inadequacy. Regarding charging infrastructure, currently, there hasn't been a commercially available charging system designed to charge solid-state batteries within 10 minutes yet. Developing and deploying new charging infrastructure will require significant investment. While Toyota's solid-state batteries have great potential to improve the performance and range of electric vehicles, there are still some challenges to be addressed before they can be widely manufactured and commercialized. So, can Toyota complete the goal of producing this type of battery on a large scale by 2027 according to their plan? Let us know your thoughts in the comment below. That's the end of today's episode. We hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon.